everybody, we're getting ready to do lesson 11.3 part 1 for grade 6 math today. And for 11.3 part 1, generating equivalent numerical expressions, you have 34 points on your classwork sheet. Students, have that out in front of you. And then 6 points will go into your notebook. And students, put your name, date, period here. Due date here for onliners and homeschoolers, put that in. And we'll start out, teachers and students, with today's bell work. Connect words and equations. The product of a number and 4 is 32. So the product of x and 4 is 32. 4 times x is 32. So 4 times x equals 32. Determine the placement of the equal sign. Write an algebraic equation for the word sense. So basically, you're going to have a statement here, and then a number is increased by 7.9. A number increased by 7.9 is 8.3. So write an algebraic equation for each one of these statements here. Okay, students? And teachers, give your students about 3 minutes for this. So 3 minutes. See you in 3 minutes. Okay, welcome back everybody for today's answers. Today's bell work. A number increased by 7.9 is 8.3. So what would be the algebraic expression for that? Would be this. X plus would be the increase. A number which is x plus by 7.9 is, here's your equal sign right here, is a verbalization of an equal sign, is 8.3. And then over here, 17 is, here's that is again, the sum of a number, you know what that means, and 6, so 17 is equals x plus 6. And then down here, the quotient of a number, and b, or rather in 8, I'm sorry, the quotient of a number in 8 is, you know what that means, is 4. So x divided by the quotient, this is your quotient, of a number x, and 8 is 4. And then over here, 81 is, you know what that means, students, 81 is 3 times a number. So 81 is, there's your equal sign for is, 81 is 3 times a number, 3x. So there's your bell work for today. To our lesson today. For a notebook entry here, essential question, how do you solve equations that contain multiplication or division? So we're going to find that out during this lesson, and it's under the heading of modeling equations. So going into our first classwork page here, Deanna has a cookie recipe that requires 12 eggs to make 3 batches of cookies. How many eggs are needed per batch of cookies is the question. So let x represent the number of eggs needed. We're trying to find how many eggs, so we're going to let x represent the number of eggs needed per batch. So number of batches. Here's our verbal model here. Number of batches multiplied times number of eggs per batch is or equals total eggs. So here's our verbal model here for our problem up here. And so number of batches, we know that is 3. We make 3 batches. We got 3 batches. And then this is multiply here. Multiply, this dot is another symbol for multiplication. And then number of eggs per batch would be, that's what we're trying to find out. Number of eggs per batch is x. 3x equals total eggs. We got 12 eggs. So 3x equals 12 eggs. So there's our verbal model, and then we put that into an algebraic equation here. So once you have that, the answer to this question, you can use algebra tiles to solve 3x equals 12. Or the model here is 3x equals 12. So, okay, so we're going to use tiles. Here's our 3x's here. 3x's is going to equal 12. So we have 4 across, 3 down. That's 12. So 3x's equals 12, right? So there are 3x tiles. So draw circles to separate the tiles into 3 equal groups. So we're going to divide this over here into 3 equal groups. So here's one group, here's another group, and then here's our third group of tiles. So how many tiles were there? How many 1 tiles are on each group? Remember that? This would be the solution of the equation. So here again are our 3x's. Here's our 12 tiles. 3x equals 12. How many 1 tiles are in each group? So remember, we divided them up into 3 groups. So how many 1 tiles are in each group here? 1, 2, 3, 4. So blank eggs are needed per batch of cookies. We did the division. Look for a pattern. Why does it make sense to arrange the 12 1 tiles in 3 rows instead of 4? Or rather, 12 1 tiles in 3 rows of 4 instead of any other arrangement of 12 1 tiles, such as 2 rows of 6. Why didn't we do it that way? Well, because 3 rows are evenly divisible by 3. So we're already dividing here by 3. In a way, by putting them in 3 rows, we've already divided them by 3. And oh, by the way, there are 4 eggs that are needed per batch. So how many 1 tiles are in each group here? There's 4 tiles in each group. Okay, that's nice to know. Using division to solve equations. Separating the tiles on both sides of an equation, mat, which is what we did in the previous page, into an equal number of groups models dividing both sides of an equation by the same number. So that's something to remember there when using tiles to visually represent a division problem. So division property of equality, you can divide both sides of an equation by the same non-zero number and the 2 sides will remain equal. So when an equation contains multiplication, solve by dividing both sides of the equation by the same non-zero number. So that is the division property of equality. So using that property, we're going to go into example 1 here. Solve each equation, graph the solution on a number line. So we have 9a equals 54. So how do we solve that? 9a equals 54. Notice that 9 is multiplied by a. So we have, here is 9a equals 54. So 9a equals 54. So what do we divide both sides of, students? What do we divide? We're going to divide here by 9. This is going to isolate our a. What we divide this side by, we have to divide both sides by. So this becomes a. A equals what? So 54 divided by 9. What's 54 divided by 9? Is 6. So there it is. We got that one. And then here's your plot of that solution on a number line. So there's your graph, the solution on a number line. Right there. Okay, moving on to another section here of this. So check 9a equals 50. How do we check a problem like this? We plug in what we got, right? 9.9 times 6, does that equal 54? Substitute 6 for a. And what do we get here? We get 54. Does 54 equal 54? It sure enough does. So when you multiply on the left side, we get 54. So B here, 18 equals 6D. So 18 equals 6D. What do we do here? Notice that 6 is multiplied by D. It's 6 times D equals 18. So to solve for D, what do we divide both sides of the equation by? Divide both sides of the equation by 6. And then we're going to plot that. So we got 3 here. Somehow we got a 3 here because we divide 6 over here, 18 divided by 6. And then 6D divided by 6 will just leave D, right? So 18 divided by 6 will be 3. And then this 6's here will cancel. Then we're just left with D. D equals 3. And then there's our plot there on a number line of a solution. So, and then to check on this, we plug in 3 here for D. That's 3 times 6. That would be your check on that. So the checking 18 equals 6D, we plug in our solution. Does 18 equal 6 times 3 is the question. Multiply on the right side. Does 18 equal 18? You bet it does. So it looks like 3 would definitely be the solution. Now solve the equation. 3x equals 21. So again, graph the solution on a number line. Here's 7. Here's our solution right here, 7. And that was 11.3, part 1 for grade 6 math. Animated PowerPoint math video at AOL.com for questions or course materials. Thank you very much.